Hey guys, we are working on 2.2 today. It is quadratic equations. A quadratic equation is just an equation that can be rearranged into the form x squared plus x plus a constant equals 0. And what we're going to be doing with the quadratic equations is solving them for x. All right, so generic quadratic equation is ax squared plus bx plus c equals 0. For number 1 and number 2, we're just going to practice simplifying. So this is not an equation, obviously. It just says 10, the quantity 10 plus or minus the square root of 50 over 5. And they want us to simplify it if we can. First thing you want to do is take 50 and factor it, right? Let's see if we can simplify the square root of 50. 50 becomes, you can do it however you want. You could say 25 and 2. 25 is 5 times 5, and that's 2, right? So the square root of 50 becomes the square root of 5 times 2. The 5's come out and we just get 5 square root 2. You can put 5 square root of 2 in your calculator and square root of 50 into your calculator to make sure that those are the same. Good. So now we can rewrite this as 10 plus or minus 5 square root 2 over 5. Now, you're also welcome to write it as 10 over 5 plus or minus 5 square root of 2 over 5. Those are the same. Okay, sometimes it's easier to separate them out. And then we can just divide each part, right? So we're going to divide or see if we can simplify 10 divided by 5. 10 divided by 5 is just 2. 10 over 5 is 2. Keep the plus or minus. 5 square root of 2 over 5. 5 divided by 5 just leaves us with 1, and so that's 1 square root 2. So I can simplify all of that to 2 plus or minus the square root of 2 because 10 divided by 5 is 2. The square root of 50 simplified is 5 square root of 2. 5 square root of 2 divided by 5 is just leaves us with the square root of 2 because 5 divided by 5 is 1. So you could also write it as 2 plus or minus 1 square root of 2. Good. All right, we'll do the same with number 2. Number 2, we have 3 plus or minus the square root of negative 36 divided by 6. Start with that negative 36. See if you can turn it into a factor tree. I'm going to factor it as negative 1 and positive 36, right? Negative 1 times positive 36 gives me the negative 36. Negative 1 I can take out as an I, right? So now I'm just going to keep that negative 1. 36 is 6 times 6, right? You can do it different ways if you want, but so this would be, sorry, that was the ones and the ones and the arrows are getting confusing. So that's negative 1, that's just 6, and that's 6. Negative 36 is equal to 1 times 6 times 6, right? So that means the square root of negative 36 becomes the square root of negative 1 times positive 6 times positive 6, which is 6i, right? Because that negative 1 becomes the I, and the 6 times 6 become the 6. So I'm going to rewrite that right here. Instead of 3 plus or minus the square root of negative 36, I'm going to say it's 3 plus or minus 6i over 6. Now we're going to do that same thing that we did up there. You can either separate it out into two different fractions, 3 over 6 plus or minus 6i over 6, or you can leave it like that. 3 divided by 6. That turns into 1/2. Why? Because it's 3. 6 is, if I factor out 6, it's 3 times 2. The 3's cancel, so I have 1/2 remaining. So that becomes 1/2 plus or minus 6i divided by 6 just leaves us with I, because 6 divided by 6 is 1. So my final answer there is 1/2 plus or minus I. Good? All right, so that's just simplifying a fraction or a rational expression. Solve using the square root property. If a quadratic equation only has a squared term and a constant, so there's no middle x, there's bx is not there, you can solve it using the square root property. So that would just be ax squared plus c equals 0. So you want to isolate the squared term by itself on one side of the equation, take the square root of both sides of the equation, and use the plus or minus. All right, so if I had x squared equals 4, I see that my squared term is by itself on one side, and then I'm going to take the square root of both sides. So the square root of x squared is equal to the square root of 4, but we're going to include a plus and a minus. Why? I'll show you. So the square root and the square root and the squared symbol cancel each other out to just leave me with x equals plus or minus square root of 4. The square root of 4 is 2, so x is plus or minus 2. I can also write that as x is 2 and negative 2. I can also write it as negative 2 and 2 in brackets. So they're just different ways to write the same answer, okay? Why do we use plus or minus? Because here we're saying what number when I square it, right? So the original equation was x squared equals 4. We're saying what number when I square it will give me 4? Well, it's 2, right? 2 squared is 4, but also negative 2 squared is 4. So there are two different answers, the positive version of the answer and then the opposite, the negative version of the answer. Good? All right. So don't forget to use the plus or the minus because it's not only 2, it's also negative 2. And then you finish solving for x if needed finish solving x if needed. Number 1, use the square root property to solve the equation. We have x squared plus 4 equals 0. I'm going to get the x squared alone by subtracting 4 from both sides. So now I have x squared equals negative 4. What I'm going to do, I'm going to take the square root of both sides because that's alone now. When I take the square root, I need to include a plus and a minus. I never leave enough space for it. So the square root of x squared is just x equals plus or minus square root negative 4. How can I simplify the square root of negative 4? Well, negative 4 becomes negative 1 and 4. Negative 1 is just I. 4 is 2 times 2. So negative 4 is 1 times 2 times 2 plus or minus the square root of negative 1 times 2 times 2. The negative 1 becomes I, no negative I. And the 2 times 2 becomes 2. So x equals 2i. But I forgot the plus or minus. Told you I always forget it. So I'm going to say that the answer is negative 2 and 2, or you can just say x equals, oh, sorry, negative 2i, 2i. X equals negative 2i and 2i, or you can just say x equals plus or minus 2i. Good? All right. Number 2 says x squared minus 100. We want to get the x squared alone, so we'll add 100 to both sides. X squared equals 100. Take, oh, again, I didn't. X squared equals 100. Take the square root of both sides. So now I have plus or minus square root of 100. X equals plus or minus square root 100. The square root of 100 is 10 because 10 times 10 equals 100. So x is plus or minus 10. X is negative 10 and 10, or negative 10 and 10. All right, so I know that these aren't fun, the square roots, but with practice, with just like seeing how you do it, it can be simple if this is a perfect square, right? Or a negative perfect square, because then you can just call it the perfect square with an I behind it. Here we have 25x squared minus 16. We want to isolate this term by itself. 25x squared. We're going to add 16 to both sides equals a positive 16, right? All right, so let's look back at our steps. Isolate the squared term by itself on one side of the equation. We did that. Take the square root of both sides of the equation. We can take the square root. Square root of 25x squared equals positive and negative of the square root of 16. Now, the square root of 25 is 5, and the square root of x squared is just x. The square root of 16 is 4, right? So now I have 5x equals plus or minus 4. Now, finish solving for x. X is not alone yet, so I'm going to divide it by 5. Divide it by 5. I still have two different answers, okay? X is plus or minus 4/5. X is negative 4/5 and 4/5, or that other version, like that 10, negative 4/5 and 4/5. Okay. You could have also, before you took the square root, you could have divided. So if I had 25x squared equals 16, I can go ahead and divide by 25 right now. Just if you're curious, I think it's easier to do it the other way. So that cancels and I get x squared equals 16 over 25. Now I'm going to take the square root. Oops, sorry. Square root of x squared equals the positive or negative square root of 16 over 25. So that just gives me x is the square root of 16 over the square root of 25. With that plus or minus in front, the square root of 16 is 4. The square root of 25 is 5. So it still says x equals plus or minus 4 over 5. You get the same answer. Good. All right. For number 4, we're going to continue using the square root property because everything on the left is squared. So we can just go to the square root of 3x plus 3 squared equals plus or minus square root of 36. Good. That cancels that, so we're just left with 3x plus 3 equals plus or minus the square root of 36 we know is 6, right? Okay. Now I'm going to break it into two different answers. 3x plus 3 equals 6, and 3x plus 3 equals negative 6. Now solve for x, so I'll subtract 3. 3x equals 3. Divide by 3, and I get x equals 1. Over here, subtract 3, and I get 3x equals negative 9. Divide both of those by 3, and I get x equals negative 3. So my two answers for number 4 are x equals 1 and x equals negative 3. Number 5 is very complicated if I wouldn't worry about it. Okay, I will do it, but I wouldn't worry about it. This would never be on an exam. So number 5 is x plus 2 squared equals negative 18. So we're going to take the square root of both sides. You just get x plus 2 over here equals positive or negative square root of negative 18. Negative 18 can become negative 1 and 18. That remains negative 1. 18 becomes 9 and 2. That stays -1. 9 becomes 3 times 3. 2 remains 2. So the square root of -18 is also the square root of -1 times 2 times 3 times 3. I can take out that -1 as an I. I can take out that 3 times 3 as a 3. And I'm just left with the square root of 2 equals x plus 2. Okay, so right now I have x plus 2 equals plus or minus 3i square root of 2. Now, I need to subtract 2 from both sides, but I have the positive version and the negative version. So just like here, once we had the positive and the negative version and we needed to subtract something, we split it into 2 different equations. So my 2 equations are x plus 2 equals 3i square root 2. And here is x plus 2 equals -3i square root 2. Let's subtract 2, and I get x equals -2 plus 3i square root 2. And here I'm going to subtract 2, and I'm going to get x equals -2 minus 3i square root 2. Those are my 2 answers for number 5. Good? Okay. Number 6, we can also use a quadratic equation is any equation of degree 2. The general form is ax squared plus bx plus c equals 0. Solving quadratic equations is different than solving linear equations where your goal is to isolate the variable. So here is what you're going to do. You want to get all of your terms to one side so that you can say the whole quadratic equation is equal to 0. You want your leading term to be positive. So you want that to be a positive x squared or a positive 49x squared, okay? Factor both sides if you can. Set each factor to 0 and solve. And if you can't factor, quickly solve by using the quadratic formula. The quadratic formula is x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Good? So if you don't like the factoring, you can do this every single time, okay? Remember, you have ax squared plus bx plus c equals 0. So whatever your constant is, you put it right there, including the sign, okay? So if it's a minus c, you'd put a negative term right there. Whatever's in front of your x is also multiplied by the -4, and down here it's multiplied by the -2. So you're just plugging terms in, okay? And then that term goes right here and right here, okay? Notice that negative sign, notice that negative sign, notice that plus and minus sign. Make sure if any of these are negative, you include that in when you factor in, or sorry, when you substitute in the term, okay? And you want to make sure your equation is set equal to 0. Good? Okay. Before you can fully use the quadratic formula each time if you want. You can also try to factor it, okay? So we've done factoring in this class before. What you want to do is you want to look at your A and your C, and you want to say, I want to find 2 terms that multiply to equal A times C, and that also add to equal B, right? My A times C in this case is 45, so they need to multiply to equal 45. And they need to add to equal -14. That negative sign goes with the middle term. Good. Then we can just list our factors of 45. 45 is 1 and 45, but I see that this is a negative, so I'm going to put them both negative. Negative 1 times negative 45 gives me a positive 45, and if I add them, I'll get a negative number. You can also do 45 is 3 times 15, right? 45 divided by 3 is 15. 45 divided by 5 is 9. Yeah? So you can do negative 3 and negative 15. You can also do negative 9 and negative 5. Negative 1 times negative 4 is a positive 45. Negative 3 times negative 15 is a positive 45. Negative 9 times negative 5 is a positive 45. When I add these, I don't get 14. When I add these, I don't get 14. But if I add these, they will equal negative 14. So my two terms are negative 9 and negative 5. What do I do once I found those terms? I put them in here, right? I factor x squared minus 14x plus 45 to x minus 9 times x minus 5 equals 0. Now, take each of those factors and set them equal to 0 and solve for x. So x minus 9 is 0. Add 9 to both sides and I get x equals 9. X minus 5 equals 0. Add 5 to both sides and I get x equals 5. So my two answers for number 7 are x equals 5 and x equals 9. All right. Number 8. So here I saw that I could factor this into two binomials. Here I don't have a constant, right? But I also don't have, so because I don't have a constant, I can't use the square root property. So I was using the square root property because I had a constant and an a, right? Ax squared minus the c. Here I have ax squared minus a b. What can I do here? Well, first think about, can I factor anything out of x squared minus 4x? I can in fact factor an x. So that becomes x times the quantity x squared divided by x is x. Negative 4x divided by x is negative 4 equals 0. X times x minus 4 equals 0. Those are my two factors, just like these were my two factors up here. Set them both equal to 0. X equals 0. Done. Nothing left to solve. X minus 4 equals 0. Add 4 to both sides and I get x is 4. So my answer here is x equals 0 and 4 or 0, 4. Good. All right. For number 9, we have x squared minus x equals 30. Remember, the first step is always to get all your terms to one side so you get 0 on the other side. You need to keep your x squared positive. X squared minus x equals 30. I want it to all equal 0, so I'm going to move that 30 over. It's being added, so I'm going to subtract it. That becomes x squared minus x minus 30 equals 0. Good. Now I'm looking at it. Can I factor anything out of x squared, negative x, and negative 30? I cannot, but I can now try to factor it, right? Let's see if we can factor it. We want two terms that would multiply to equal a times c, and that would add to equal b. That means they need to multiply to equal negative 30, and they need to add to equal negative 1. Okay, if they're multiplying to a negative, that means one term needs to be positive and one term needs to be negative. If they're adding to a negative, that means that the term that is bigger needs to be the negative term. So negative 30 could be 1 and negative 30. That's not going to give us negative 1 if we combine them. It could be 2 and negative 15. It could be 3 and negative 10. It could be 5 and negative 6, right? And that one will work, right? 5 plus -6 gives me -1. So this becomes, keeping that 0 right there, x squared minus x minus 30 becomes x plus 5 times x minus 6. Now I have x plus 5, set it equal to 0, subtract 5, and I get x equals -5. Here I have x minus 6 equals 0. Add 6 to both sides, and I get x equals 6. So my two answers are x equals -5 and x equals 6. I'm going to do the same thing here. I'm going to make sure that all my terms are on one side, so it's set equal to 0. So I'm going to subtract 15x, subtract 15x. I'm just going to put it right in order right away. X squared minus 15x minus 16 equals 0. I can't factor anything out of that. I want two terms that multiply to equal a times c and that add to equal b. A times c is -16. So they should multiply to equal -16 and they should add to equal -15. We can do 1 and -16. If I add those, I do get -15. So we're done. X plus 1 times x minus 16 equals 0. Now just take each of those and solve each of the factors. X plus 1 is 0. Subtract 1 from both sides and get x is -1. X minus 16 is 0. Add 16 to both sides and get x is 16. If you were to, once you have it like this, if you were to put it into this equation, you would get these two answers. All right, here we have 84x minus 11 equals 49x. I'm just going to give myself a little more space. 84x minus 11 equals 49x squared. Again, I want to make sure that my leading term, which is the x squared term, is positive. So I'm going to move over these two to over here so that it's 0 equals. Good. So 84 is being added. I'm going to subtract 84x, subtract 84x. You can do it in one step if you want, but I'm going to do two. So now I have -11 equals 49x squared minus 84x. Now I'm going to add 11 to both sides. 0 equals 49x squared minus 84 plus 11. Good? All right. Is there any number that I can divide out of 49, 84, -84, and 11? I also forgot to put the x. I apologize. Is there any number I can factor out? No. And if I were to factor it, right? If I were to factor it, then it would be like, okay, I got to multiply to equal 49 times 11, and I got to add to equal -84. Those are really big numbers. I don't love it, right? So I might just put it into the quadratic formula. The quadratic formula, if we remember, is x equals -b plus or minus the square root of b squared minus 4 times a times c divided by 2a. This is a. This is b, including the negative. And this is c. So we've got x equals negative, what's b? 84. -84 plus or minus the square root of b again, so -84 squared I forgot that b comes with the negative, so it's negative 84. Whew, that would have been bad. Minus 4 times a, which is 49, times c, which is 11. All over 2 times, make sure we have it in parentheses, times 49. So I don't know which looks easier, to do that or to try to figure out that. I'm going to do this because we haven't yet. So x equals negative 48 becomes a positive 48, sorry, 84. Negative 84 becomes positive 84 plus or minus this negative 84 squared is 7,056. 7,056 minus 4 times 49 times 11, 2,156, divided by 2 times 49, it's going to be 98. 49 times 2, 98. Sorry, that wasn't a great angle. So we've got x equals 84 plus or minus the square root of, I'm going to take 7,056 and subtract 2,156. To get, 49,000 divided by 98. Good. Let's just put this right into our calculator. So you're going to take the square root of 4,900 to get 70. So now that's gone. The square root of 4,900 is just 70. So now we have x equals 84 plus or minus 70 over 98. 84 plus 70 is 154 divided by 98. So now you can factor out 154. What's the factor tree of 154? What's the factor tree of 98? And start canceling. You can also go over to Desmos and say, I've got a fraction that is 154 divided by 98. It'll give you the decimal on this side, convert to fraction, and we get 11 over 7. I just remembered, sorry. I just remembered that we can't just add the 70. There's one version where we added 70. And there's a version where we have to subtract 70, right? 84 minus 70 is 14. So that wasn't super graceful, but basically you got the 84 plus 70 over 98 becomes 154 over 98. And then you've got the 84 minus 70 over 98 becomes 14 over 98. Now we can simplify them. 154 divided by 98, 14 divided by 98. Go over to your calculator, or you can factor it out. You're welcome to factor it out. But we got that 154 over 98 is equal to 11 sevenths, and that 14 over 98, press that fraction button, is 1 over 7. So my two answers are 11 sevenths and 1 seventh. X equals 1 seventh and 11 sevenths, because that was all x equals. Good. All right. So that's number 11. All right, for number 12, we've got x squared minus 4x minus 13 equals 0. I'm going to write that on a different piece of paper. All right, we've got x squared minus 4x minus 13 equals 0. Now, you can look at this. You can say, can I factor anything out? I can't factor anything out. There's no common factors. I can try the multiplication, right? Multiply to equal negative 13, add to equal negative 4. The problem with this is that there are not a ton of numbers of factors of negative 13, right? You could say negative 13 and 1, or you could say positive 13 and negative 1. Neither of those are going to add to equal negative 4, right? So I think for 12, we're going to have to go to the quadratic formula. Now remember, we've got x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. My a is right here, it's 1. My b is negative 4, and my c is negative 13. So we'll start there. A is 1, that was 1x squared. B is negative 4, because that's negative 4 times x, and C is negative 13. Good. So we got it all equal to 0. We found A, B, and C, and then we're going to put them into the equation. Equation is x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Now I'm going to substitute those numbers in, all right? X equals negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 13 divided by 2 times 1. Good. Now we'll just simplify. X equals minus negative 4 is a positive 4 plus or minus the square root of negative 4 squared is 16. Negative 4 times 1 times negative 13. So I'm going to go negative 4 times 1 times negative 13. Negative 4 times 1 times negative 13 gives me 52. So plus 52, because a negative times a negative makes a positive. Divided by 2 divided by 1 is just 2. That gives me 4 plus or minus the square root of, let's combine 16 and 52. 68. 4 plus or minus the square root of 68 divided by 2. Now what we're going to do is we're going to make a factor tree for 68. 68, you can just divide it by, what do we think it divides by? 68 divided by 4. You can start with 2 if you want. 4 and 17, in fact. 4 becomes 2 times 2. 17, there are no factors of 17 besides 17 and 1, so we just leave it as 2 times 2 times 17. So that becomes the square root of 68 is the square root of 2 times 2 times 17. So that becomes 2 square root 17, right? So now I have 4 plus or minus 2 square root of 17 over 2. 4 plus 2 square root of 17 over 2, and 4 minus 2 square root of 17 over 2. You don't need to separate them if you don't want. This just reminds me that I need to have 2 answers by the end. You can also separate this out further and say this is 4 divided by 2 plus 2 square root 17 divided by 2, and that this is 4 divided by 2 minus 2 square root of 17 over 2. Now we know that 4 divided by 2 is 2, and then 2 square root of 17 divided by 2 just leaves me with the 17. Same here, 4 divided by 2 is 2, minus 2 square root of 17 divided by 2 is just square root 17. So those are my final answers. You can also get it from here. 4 divided by 2 is 2. 2 square root of 17 divided by 2 is just square root of 17. Same over here. 4 divided by 2 is 2. 2 square root of 17 divided by 2 is square root of 17. So those are my answers for number 12. So number 12 is 2 plus square root of 17, 2 minus square root of 17. All right. Number 13 says 2x squared plus 10x plus 3. Can we factor anything out of that? We can't. Can we factor it into two binomials? We would need two binomials, or we would need two terms where they multiply to equal a times c, which is 6. And then we would need them to add to 10. So two numbers that multiply to 6 and add to 10, so they would all be positive. 1 and 6, 2 and 3. No. Unfortunately, none of those add up to 10. So we can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. X equals negative 10 plus or minus the square root of 10 squared minus 4 times 2 times 3 divided by 2 times 2. Negative 10 plus or minus 10 squared is 100. Negative 4 times 2 times 3. Negative 4 times 2 times 3 gives me negative 24. 100 minus 24 divided by 2 times 2 is 4. So x equals negative 10 plus or minus the square root of 100 minus 24 is 76. Just to be sure. Divided by 4. Can I take that 76 and factor it at all? So 76, I don't really know 76, so I can just divide it by 2. 38, so it's 2 and 38. 2 just remains 2. 38 I can divide by 2 again. And I get 19. 19 I don't think I can factor into anything, right? So square root of 76 becomes the square root of 2 times 2 times 19. Which becomes 2 square root of 19, right? So now I've got x equals negative 10 plus or minus 2 square root of 19 over 4. And now I can just factor that out. Negative 10, or I can divide it out. Negative 10 divided by 4. Negative 1 times 5 times 2 divided by 2 times 2 gives me negative 5 halves. And then 2 square root of 19 divided by 4. 2 square root of 19. 4 becomes 2 times 2. And I get square root of 19 over 2. And I can rewrite it as negative 5 plus or minus square root of 19 all over 2 is my final answer for number 13. Negative 5 plus or minus square root of 19 over 2. Good? All right, number 14. I feel like we already did this exact problem, right? That's the same as that, so I'm just going to not do it. It's negative 2i or 2i. You can put it into the quadratic formula. You'll get out the same answer. All right, 15, we've got 2x squared plus 12x equals negative 5. Again, you want to set the whole equation equal to 0, so I'm going to move that 5 over. And I get 2x squared plus 12x plus 5 equals 0. Good. Now, can I factor that? Is there anything that will multiply to equal 10? Because that's x, a times c is 10. And it will also add to equal 12. Also, I should have checked to see if I could factor anything out, but I don't think I can. All right, 10 factors of 10 are 10 and 1 and 5 and 2, right? Not quite factorable. Or sorry. So this whole thing is not quite factorable because none of those equal 12. So we'll put it into the quadratic equation. X equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. Negative, the b is a positive 12, right? Plus or minus the square root of 12 squared minus 4 times 2 times positive 5 divided by 2 times 2. Let's simplify that. X equals negative 12 plus or minus 12 squared is 144. Negative 4 times 2 times 5 is negative 40 over 2 times 2 is 4. 144 minus 40 is 104 over 4. Good. We can try to see how we can factor 104. So 104 is just 52 and 2, right? 52 would be 26. 52 divided by 2 is 26. Two remains 2. 26 divided by 2. 13. So the square root of 104 becomes the square root of 2 times 2 times 2 times 3, which, all right, so the square root of 104 is the square root of 2 times 2 times 2, 2 times 2 times 2 times 13. Made a mistake there. All right, which is 2 times 13 times 2, which is 2 square root 26. Good? All right, so x equals, we're right here, right? X equals negative 12 plus or minus, instead of the square root of 104, we have 2 square root 26 over 4. Now, I'm going to factor this. Negative 12 becomes negative 6 times 2. This stays the same, even though I wrote it in the wrong order. And then 4 becomes 2 times 2. And then I see that each of these has a 2 I can cancel. And that becomes negative 6 plus or minus the square root of 26 over 2 as my answer for number 15. Good? Okay. Number 16. Second. Number 16 is x squared minus 12 plus 52 equals 0. So A is 1, B is negative 12, C is 52. Make sure you couldn't divide anything out. We couldn't divide anything out. So x equals negative b, so negative 12, plus or minus the square root of b squared, so negative 12 squared, plus, or no, sorry, minus 4 times A times C divided by 2 times A. That becomes X equals negative 12 becomes 12 plus or minus, sorry, I forgot X up there. The square root of negative 12 squared is 144. Negative 4 times 52 is negative 208 divided by 2. Good? So that's 12 plus or minus 144 minus 208. 0.8, 208 is negative 64 divided by 2. I guess I should keep putting an X in front of it, right? What's negative 64? Negative 64, the square root of negative 64 means we take that 64 and we say it's negative 1 times 64. That negative 1 remains negative 1. 64 is 8 times 8, right? So the square root of negative 64 is the square root of negative 1 times 8, which is 8i. So that becomes x equals 12 plus or minus 8i over 2, which is 12 divided by 2 is 6, plus or minus 8i divided by 2 is 4i. So for number 16, we've got 6 plus or minus 4i. 6 plus 4i, 6 minus 4i. And number 17 is our last one. So we've got 4x squared plus 1 equals 3x. I'm going to move that 3x over. 4x squared plus 1 equals 3x. I'm going to move that 3x. And I've got 4x squared minus 3x plus 1 equals 0. All right. Can I factor anything out? I cannot. Anything that I can multiply to equal 4 and add to equal negative 3? Well, I could do negative 4 and negative 1. I could do negative 2 and negative 2, but none of those add to equal 3. So we'll just do the quadratic formula. X equals negative b, right? Negative 3 plus or minus the square root of negative 3 squared minus 4 times a times c divided by 2 times a. X equals negative 3 means positive 3 plus or minus this negative 3 squared is 9. 4 times 4 is 16, so 9 minus 16 divided by 2 times 4 is 8. Good. 9 minus 16 gives us negative 7. So we've got x equals 3 plus or minus the square root of negative 7 over 8. What can we do with 7? The square root of negative 7, if I factor it, it's just negative 1 and positive 7. I can't really factor 7 any further. So that becomes x. Well, I don't need the x. X equals 3 plus or minus I square root 7 over 8. And that is how I would leave it. All right, guys, that is practicing with the quadratic formula or just solving quadratic equations. Thanks so much.